Here I have a wooden surface and a block with some masses on. It is passed by a string which goes over a pulley to this small mass here. What I'm going to try and do is to find the coefficient of friction between this wooden block and the wooden surface, and then test that using the idea of the angle of friction. At the moment the system is at rest, and if I tap on here there is no movement, so it seems that the friction is quite adequate to overcome the tension in the string. If I now add another 10 grams to here and tap, you can see that the block just begins to slide. I'm going to take this as being on the point of sliding. The diagram shows the forces acting on the block and the suspended mass. Considering the suspended mass first, if these forces are in equilibrium, T will be equal to 0.06 G. Now considering the block, we have the weight, normal reaction, the tension from the string and the friction force. Considering the vertical forces, R will be equal to 0.364 G and F will be equal to T, but we know that T is equal to 0.06 G. If the block is on the point of sliding, F will be equal to mu R. Substituting the values that we've got, we have 0.06 G over 0.364 G, which gives us a value for mu of 0.16. The angle of friction tells us that when the block is on the point of sliding, tan alpha, where alpha is the angle between the slope and the horizontal, will be equal to mu. So in this case, our angle alpha will be equal to the inverse tan of 0.16, which gives us a value of 9 degrees. I've now set the slope at 9 degrees to the horizontal. When I put the block on the slope and release it, the block slides very, very slowly indeed, suggesting that our prediction for mu is quite accurate. If I reduce the angle slightly and put the block on the slope, it remains at rest.